this is from the first chapter of class 11th physics, units and measurements. So it's physics, dimensions. Okay, what's the first thing that comes to your mind when you think of about dimensions? We know 2D, 3D, those are all dimensions. 4D, we go to movies to see 3D films. So those are all dimensions of a film. Like, instead of seeing a film on a flat space, that's, if we see it on a flat space, it's called 2D. If we see it coming close to you, that's 3D, where this axis is also included. So these are some dimensions. But in physics, dimensions have some other meaning. Now, I bet you have learnt about the 7 fundamental quantities. What are the 7 fundamental quantities? We know there's length, mass, time, electric current, temperature, luminous intensity, and then there's amount of distance, right? And these are all measured in a certain SI unit. For length we have meter, mass we have kilogram, time we have second, current we have ampere, temperature we have Kelvin, luminous intensity we have candela, and for amount of substance we have mole. Right? Now with these 7 base quantities, we explain what are dimensions. What are the dimensions of physical quantities? Now we know we can derive some quantities which are called derived quantities from these base quantities. We have other quantities like speed, right, or voltage. These are all derived quantities. So for these derived quantities, dimensions show how much dependence these quantities are to these fundamental quantities. Like, for example, speed does not depend on current, right? So if speed were to depend on current, there would be some speed's unit is meter per second, and we know meter is length and second is time. There's no trace of current or temperature or luminous intensity in this value. So for the dimensions of this, we represent dimensions as dimensions of a physical quantity are the powers or exponents to which the base quantities are raised to represent that value. So for speed we have meter per second. So we can, as dimensions, we can represent this as meter. That's length. So we represent length as L, mass as M, time as T, current as A or sometimes I, temperature as K, luminous intensity as CD, and mole, amount of substance as mole itself. So speed is dependent on length, meter, and second, time. Here we know it's meter per second. Second is on the denominator. So what is this raised to? This is raised to -1. -1 would mean L divided by T. So this would be the dimensions of this physical quantity. So what are dimensions? Dimensions are the powers to which the base quantities are raised to represent that value. So in this dimensions, we don't see the trace of kilogram or current or temperature or luminous intensity or mole. We only have L and T. So what do we understand? Speed is dependent on only these two base quantities, L and T, where L is raised to 1 and T is raised to -1. So dimensions solely represent how much dependence of quantity has to the fundamental quantities, right? Do you understand? So for voltage also, voltage is actually represented as volt, but if we derive it as base quantities, we can get kilogram, meter square, second raised to -3, ampere raised to -1. So this is the actual unit of voltage, and if we represent this as dimensions, we can see it's dependent on mass. So mass, meter square, so L, time is S, and A is current, and we can raise it to 2, -3 and -1 respectively. So we see voltage is dependent on mass, length, time, and current passing through the material. It does not depend on temperature, luminous intensity, or amount of substance. So dimensions solely represent to what degree a quantity is dependent on the base quantities. Okay. What is zero dimension? So I told dimension means how much dependent a derived quantity is to the 7 fundamental quantities. It is like a measure to estimate the degree of how much a derived quantity is dependent on a base quantity, right? So what is zero dimension? Zero dimension would mean it is independent of that base quantity. So for example, in the previous example we saw speed, right? Speed has dimension L t raised to minus 1. Here we don't see mass, we don't see current, we don't see luminous intensity, we don't see temperature. So such we can write all the dimensions if we want. If we write M, L, T, A, K, C, D, mole, if we write all the dimensions, we can see it's only dependent on L and minus 1. All these other dimensions are raised to 0. What does raising them to 0 mean? M raised to 0 is 1. So even if we don't write that, there is no specific use. But zero dimension means the power would be 0. That would mean it is independent of that fundamental quantity. So it's not dependent on mass. So the speed of an object is not dependent on the mass of the object. It's not dependent to the current flowing through that object. It's not dependent on the temperature of the object. It's only dependent on the length, the distance which it traveled, and the time in which it traveled. It took to travel that much distance, right? So speed is so we write L t raised to minus 1, and it is understood that the other fundamental quantities are raised to 0, hence they are in zero dimension with those quantities. I'll give you another example. Let's say for example volume, right? We know volume is what? Volume is length into base into height, right? Length into base into height, and SI unit is meter cube. What is meter cube? Meter is length, so length cube. It's not dependent on any other quantity, right? So volume is independent of mass, time, and other fundamental quantity. It is only possessing dimensions in length, which is raised to 3. It is 0 dimension in mass, 0 dimension in time, and 3 dimensions in length. Volume depends on the 3 dimensions of length, but it's not dependent on this mass, time, ampere, Kelvin, candela, mole. Okay, so we can say volume is independent of the other quantities except length, where length has 3 volume. Thing called dimensional equations. Dimensional equations. It's when we equate a physical quantity with its dimensional formula. So for example, it's pretty simple. If we want to find the dimensions of F, so we write F, the square brackets means we are finding the dimension of that, which would equal to, what is it? Force? Force is mass into acceleration. So we know mass into acceleration. Acceleration is meter per second square. So meter per second square, so it's minus 2. So m raised to 1, L raised to 1, t raised to minus 2. So these would be the dimensions of force. So this is called a dimensional equation. It is when an equation obtained by equating a physical quantity with its dimensional formula. It's pretty easy. We just equate the physical quantity with its dimensional formula, as we did with voltage in the previous case, right?